Hello YouTube, this is Gaurav here and welcome to my channel. Understanding hierarchical clustering is confusing for most beginners, while it stays an important concept. Well, here I am to take away all your confusions regarding this and will be going through the concept in detail and also execute a simple code which will sum up the whole concept. So without wasting any time, let's get started. Understanding the concept of clustering first, clustering is a technique that groups the similar objects such as the object in the same group that are more similar to each other than the objects in other group. The group of similar object is called a cluster. For example, clustering customers based on any sales, purchase activities, interest, profession and many more factors. It can be also applied to cluster products based on geographical conditions, sales, purchase and many more things. Now what exactly is hierarchical clustering? It's also known as hierarchical cluster analysis is an algorithm that groups similar objects into groups called clusters. The endpoint is a set of clusters where each cluster is distinct from other cluster and the objects within each cluster are broadly similar to each other. So hierarchical clustering starts by treating each observation as a separate cluster. Then it repeatedly executes the two following steps. Firstly, identifying the two clusters that are closest together and secondly, merging the two most similar clusters. Now this is an iterative process which continues until all the clusters are merged together. Seems a bit confusing, right? So let's understand this with a simple example. Now coming towards this example, we have 6 data points, that is A, B, C, D, E and F. Now what hierarchical clustering will do, it will cluster the most similar data points. So in this diagram we can see E and F are much more closer to each other. So it will be clustering E and F under one cluster as this. And later we can see that A and B are much more closer before D with E and F cluster. So it will be clustering A and B first. Later, we can see that D is much more closer to E and F cluster. So it will be clustering D along with E and F. Now similarly, C will be clustered along with the cluster D, E and F since it's more closer than A and B. And finally, it will merge every data point under a single cluster. Now the main output of hierarchical clustering is a dendrogram which shows a hierarchical relationship between the cluster from which we can select the optimal number of clusters to be used for our clustering, and this is how a dendrogram looks like. We have E and F the first cluster, later A and B was clustered and then D was included with E and F and so on. Later we can use agglomerative clustering from our sklearn library, which will recursively merge the pair of clusters, where the optimal number of clusters will be the one which we have selected from our dendrogram. Now you would be wondering, what is the measure of distance, like on what basis these clusters are formed? The simple answer here is Euclidean distance. This is the general measure of distance followed here, which is simply the length of straight line between one cluster to another. Isn't it simple? Well, there are other advanced distance metrics for more accurate results, but Euclidean distance stays a decent choice for basic applications. Well, this was all about the basic hierarchical clustering and general concept behind it, and I'm sure it served helpful. Now let's understand how can you apply these concepts in a code. Let's dive into our coding and apply these concepts to a simple data set. Now before starting with the code, let's understand what's the data set we are using. So I'm using mall customer segmentation dataset. This is the same data which I had used for explaining the k-means clustering. So this data includes customer ID, gender, age, annual income, and spending score. So basically our goal is to segment the customers based on their annual income and their spending score. Now coming towards the code, first we'll be importing important libraries such as pandas and numpy and matplotlib as PLT. Now here we'll be importing our dataset using pt.readcsv and the file path. Now once we are done importing our data, and we'll save this in our variable df. Now let's print df.head and we can see our data clearly over here. Now since we are interested in just annual income and spending score, we'll be extracting those particular column values in our new variable x using df.ilog and the column index 3 and 4, that is our annual income and spending score. So let's execute this and let's print the first value of our x, that is 15 and 39. So we are getting 15 and 39 just to ensure that our values are extracted properly. Now here we come to an important step. We'll be using dendrogram to find the optimal number of clusters we'll be using for our clustering. Now for that purpose we'll be importing hierarchical cluster from SciPy as SCH, and we'll be creating a variable dendrogram is equal to sch.dendrogram, sch.linkage, and passing our data x and method will be what. Now here we'll be mentioning the title x label, y label, and let's execute this. Now as you can see, our dendrogram has been created, and wherever it finds the data points it will be clustering those until a final cluster is formed over here. Now there is no specific rule on what basis we can select our optimal number of clusters, but generally speaking, when the distance between the two stages, say this stage and this stage, when the distance between the two stages is too high, that's the point where we get our optimal number of clusters. Now, how can we calculate how many number of clusters do we have? Now, for that purpose, we'll be plotting an horizontal line, let's say 200. We'll be cutting the vertical lines of these stages, and the number of lines cutted are the number of optimal clusters we have. Now let's say we plot a horizontal line of from here. So we have cutted this, 3, 4, and 5. So in this particular case, we have 5 optimal clusters with us. Now once we have got that optimal number of clusters are 5, we'll be training our cluster model on our data set. Now for that purpose, we'll be importing agglomerative clustering from sklearn.cluster, and we'll be storing our agglomerative clustering where we'll be initiating n clusters as 5, which are the optimal number of clusters. Linkage is what, as we did for previous one, and affinity is Euclidean, that is the Euclidean distance between the clusters, between the data points, and we'll be saving this model in our variable hc, and finally we'll be executing hc.fitPredict x, which is our data. So let's execute this. Now once we have done model training, we'll be saving the predictions in yhc. Now here, since we have 5 optimal clusters, we'll be plotting each cluster. So let's visualize this. We'll be selecting cluster number 1. We'll be mentioning the size as 100, color as red, and label as cluster 1. Similarly for cluster 2, cluster 3, cluster 4, and cluster 5, we'll be assigning the title, X label, and Y label, and we'll be also enabling the legend. Now let's execute this. Now as you can see, we have got a beautiful plot showing our 5 optimal clusters, and there are a number of intuitions we can extract from this. So if you can see cluster number 1, which is red color, so these are the people which are having higher annual income, but their spending score is quite less. On the other side, we have cyan color, which are the people, that is cluster number 4. These are the people who have less annual income, but their spending is higher. Well, this was all from my side, and I hope this video and my explanation was helpful. Do hit that like button and share this video with your friends. Signing off for today. Stay safe, take care, and bye bye.